I'm Batman. That's why I've got this shirt. You see me in such fine quality educational videos as Henderson Hasselbalch? Now what? Or, hey, I know that dude Henderson Hasselbalch. Today we're going to be looking at calculating pH of a buffered solution, but instead of using necessarily the ice table, we're going to try to use another way. The Henderson Hasselbalch method or the Henderson Hasselbalch method, depending on who you talk to about that. Okay, so what we have here, the basic idea is that the pH is equal to the pKa plus the log of the base divided by the acid. And that's the basic formula behind this. Okay, so if you ignore these 1, 2, 3, 4, it transferred from PowerPoint onto Word fine, and then it went from Word to the smart board. It changed the bullet points to 1, 2, 3, 4. I don't know why. So let's work with it, shall we? So here's the idea. We have a mix of NH3 and NH4Cl, otherwise known as ammonia and ammonium chloride. Okay? It says calculate the pH of the following mixture. Notice that they don't give us a Ka, they gave us a Kb. This might require a little bit of thinking here, but that's okay. We can go ahead and try to use the ice method, which I worked out on paper, but you know, this way is going to be a little bit easier for us. So let's take a look. What are the major species in our solution? Well, NH3, absolutely. The NH4, the Cl-, and the H2O. Those are our main players. And of course, this basically comes from this when it's all broken up and everything. So now that we've gotten that, let's go ahead, let's identify a few pieces here. We're not going to use the ice table this time around. We're going to try to use the Henderson Hasselbalch method. I'm sorry if I mispronounced the name. Okay. Okay, how do we go about doing this? Well, there's a couple of things that we need to know. First off, we need to know how in the world do we get the Ka? And they gave us the Kb, but we can find a way to get the Ka. And there is a formula for that. There is that dissociation constant of water. Remember how water, if you look at water in a glass, you're going to find that it's not all H2O. You've got some H3O and OH- in there, and you've got lots and lots and lots and lots of H2Os, okay? But it is equal to the constant of the acid multiplied by the constant of our base, which is what we have. Now we know that Kw is equal to 1 times 10 to the minus 14th. What does this correspond to? The pH scale, right, because if you were to take the negative log of that, guess what? Okay, so that'd be kind of important. That'd be kind of a very important thing. It helps us be able to determine a lot of chemistry for a lot of things, including living things. All right, so what we're going to go ahead and let's find our Ka first. Okay, so Ka is going to equal, well, the Kw over Kb. Right? So we need to do a little bit of rearrangement. So we need to do a little bit of plugging in information. So that's going to be 1 times 10 to the minus 14th over, this case, erase, 1.8 times 10 to the minus 5th. So we can go ahead and divide that, and we would get 5.6 times 10 to the minus 10th. Wow, that's a very tiny acid dissociation constant, but stop and think about this for a moment. If you look here, NH3, you kind of base there, and the NH4 is essentially your conjugate acid. Yeah, so anyways, we've now figured out our Ka. So if we can look at our formula now, if we look at the Henderson Hasselbalch method, it says here that the pH is equal to the pKa. So that means you're going to have to take the log of this, okay, plus the log of the base over the acid, which in this case, it happens to be 0.25 molar over 0.40 molar. Okay, so that's what this is supposed to be. All right, so what do we find about the pKa? Well, remember, you are taking 5.6 times 10 to the minus 10th. You're going to take the negative log of that, and that is going to give you your pKa. Okay, and that, when you work that out, you end up getting, so we're going to move on here, the pH is equal to 9.25 plus the log of 0.25 molar over 0.40 molar. So now some of you guys are sitting there going, wait a minute, didn't we take the pH of a negative log of something? Correct, you did. So guess what? This, when you take the log of 0.25 divided by 0.4, guess what it's going to be? A negative number. Yeah, a negative number. So in the end, what you're going to get, as I move on here, our pH, as we work through, is equal to 9.25 minus, oh yeah, we're going to minus 0.20, which is going to equal 9.05. And ladies and gentlemen, that is our answer. Yeah, this is a little bit faster than doing the ice table. And you'd say, could we do this for every one of them, please? No, you can't. How come? Well, because you have pretty large concentrations of this stuff here. Okay? So this is the Henderson Hasselbalch method. This is another way of doing it. Now, do they give you this particular formula on the exam? Yeah, they do. They do. pKa plus the log of base over acid, or the AC minus divided by HA. That's another way of looking at it. Okay? So, ladies and gentlemen, I hope this helped you out. This should be a relatively short video. And I wish you the best. Take care until the next time.